Welcome to my channel Cloud Coders. I'm Furkan, software developer, solution architect, uh, working with Swift programming language for almost 7 years. So today I'm going to discuss about a backend serverless solution to create RESTful APIs using Swift and AWS Lambda. So AWS Lambda is all about serverless solution. There's no server maintenance, and it is very fast development and deployment as well. There are so many languages you can use to combine with the AWS Lambda. Like I have worked with Java, I have worked with Scala, I have worked with Node.js, Python. You can choose anything, any tech stack, whatever you like. But as I have major experience in Swift, I'm continuously developing iOS native application, so I think it's easier for me to go ahead and explore how good Swift is as a backend development language. So Swift is continuously evolving. Swift is very stable, very mature language, and there are continuous updates from Apple to optimize compile time and performance. So this is just, you can say, is my experiment to explore things further about Swift development as a serverless solutions. So I have deployed a project. I have created a Xcode project and see things about. So here's something that I have explored, that okay, if we can develop a serverless solution, where we can reach. So and how good it is as a cost saving solution. So you can see that you can deploy an average kind of system around $3 a month. Maybe you can't believe me in first step, but you can check the link and see that I'm not wrong about it. You can check the details here, that we can deploy a good RESTful API server in minimum cost, depend on what kind of system we are going to develop. So this is something I have explored, and these are my learnings about it. And I'm going to share a link to this file in the description, so you can check the details later. So first I will show you what is the final result. So this is the Lambda function that I have deployed, connected with the API gateway, so we can access the REST API from here. It's a secure gateway solution that you can utilize with AWS Lambda. So here's the Xcode project that I have created, and for that part I am using the AWS Lambda runtime environment. And if you want to check the details of Lambda runtime for Swift, you can see the GitHub repo here to check the details. And this is all about here. So this is the Xcode project that I have for the very basic simple implementation, and I am utilizing the most latest feature like async Lambda handler to develop this Lambda functions. We have some initialization, so if you have you have to initialize some data, some variables, some connections like DB, so you can utilize your initialization here. And this is the main function where you can process any kind of event. I'm processing the API gateway events, request event, but you can process any kind of event here. And I'm using the most latest features of Swift, like structured concurrency pattern, async await. And this is really good to develop these kind of system where we are throwing some error, and we have just one output result. So it will make things easier to develop asynchronous responses with some error. And you can see that I have developed something here, but you can choose anything, but I think this is most easier and most latest things that I have utilized in my project. And let's test that this function. We can test this lambda function locally. We just need to add some environment variable, like I have added local lambda server enabled, and it's good to go. So let's run this this basic lambda functions and check that how it works locally. So I'm running this server here, and I'm going to check this welcome route. So I have this, and my server is running. That's fine. Let's run this API gateway lambda request for the welcome route, and here I get so Swift REST API server is running. The server is running fine, completely fine. If I stop that, so I have some error, so because there is no server request to be processed. So this is the lambda function that I have developed, and you can process the API gateway request, and basically this is something for example, if this is something, because event is the input request that I have, and body, I can process this string, body string, to process further. For example, in case of post request, I can process body, and then I can convert it to JSON response, or maybe I can validate it, I can process it further. So I'm going to deploy it to AWS server. So I have configured some commands about it. Let's see how things. So okay, let's try to develop some. I have basically applied some commands for AWS lambda functions to make a Docker image for that, because if we need to deploy this lambda function, we cannot directly use the AWS lambda function to just write the code there. Like in many other languages, for node.js, you can directly write your commands there. For this Swift AWS lambda function, you have to create a Docker image to deploy with all the dependencies. I am using this Swift 5.6.2 Amazon Linux to Docker image to create a Docker image with all the dependencies. It takes time, so I have already applied command. You can see the details, and I'm going to share the details in the next video, where I'm going to share with you a Git repo, and you can check the details. Currently I'm just copying this lambda functions that have created by this compiled Linux build, so I can at least deploy, and we can see the results on AWS Lambda. So lambda function has been created here, and so I am going to upload this function here. Normally we can directly upload the lambda function from a zip file here, but 10 MB is the limitation for that. So this file is around 25 26 MB, so we only have options to upload it via S3. Let's apply some test code here. So I have already mentioned some welcome route here. So this is basically API gateway structure, that if you want to apply some API gateway request, you can directly apply here with this JSON format. So I'm going to try it with the welcome route. So let's try it. Okay, so here it is. So this is response, JSON response from the server. Directly we can use this function, and here are some results that basically how much time it takes for initialization duration. There is some billing duration, that how much execution time uh, it will consume. Your billings is going according to that. So for Swift, because it's compiled Linux, so it will not take much time for execution. So we have less billing. As soon as we for the first time we have this initialization duration, but as soon as if we test it again and again, you can see that now initialization time has been gone, because our lambda function is alive and it is ready to consume the request, and now we have 1 millisecond. So our billing duration is here, which will cost you the cost is your cost is measured by this billing duration, and the memory, how much memory you allocated for these resources. My function is for Swift, you have lowest memory footprint. So maybe you can explore yourself for Node.js, that Node.js is consume more memory, but for Swift it is consume very less memory because of the compiled code on the server. And you can see some details. I'm going to share with you some details. I'm using this ARM64 architecture because I've compiled this build using my M1 machine, so it will create an ARM64. So if you are creating this build to some other system, x86 processor, so you can use that, but I'm using this ARM64, and there are some added advantage to create this kind of build, ARM64 build. I will show you some advantage in Graviton processor. So here are some advantages that you get when you use ARM64. So you have more performance with less pricing. This is really good, that what AWS provide you with the AWS Graviton processor, and you can try it for that. So guys, this is something that from my side, and in the next step I'm going to provide you the Git repo link, that how because I want to make it a complete RESTful API server where I can put any route and we can perform some CRUD operations using NoSql database MongoDB. So keep connected with me, and I'm going to share with you more details about these solutions. Thank you very much.